Mars was not always a dusty and desolate world. There is ample evidence that the planet was once warm, had lakes of liquid water, and was habitable for a brief period in its history. Researchers now hope to find traces of this era inside the planet and answers to the question of why Mars changed so drastically. What they have actually discovered shows that Mars is still alive. What does this mean now, exactly? Also, in view of the future settlement of the planet, could Mars become a living world again through clever terraforming? Stay tuned because we will now show you Mars from a completely unknown side, InSight's Mars mission in 2018. The InSight Mars lander, launched toward the Red Planet, is short for Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport. The lander was developed specifically to find out what exactly is going on inside the planet and how the core of Mars is structured. Now, you may think that this is not as exciting as exploring the surface and searching for traces of life or water, but the core has it in itself. It is only in the hitherto completely unknown center of Mars that researchers are finding the missing answers as to why Mars has developed into what it is today and why it has gone from being a possibly inhabited world to a dry wasteland. Using drills and special analysis equipment, the probe penetrates deep inside, taking seismic measurements and recording both the number and intensity of Martian quakes. In the strength of the quakes, researchers encountered a big surprise. How does the core of Mars differ from that of the Earth? To understand the explosive nature of InSight's findings, we must first look at the structure of our Earth's core. About 100 years ago, researchers first had the technology to scan Earth's interior in a very unique way. Scientists analyzed seismic waves that travel through the Earth's interior, triggered by natural events such as the movement of continental plates and even phenomena like earthquakes. Seismic waves, occurring mainly as P and S waves, travel differently through materials. P waves are pressure waves that cause rocks to vibrate parallel to the direction of wave propagation, while S waves are shear waves that vibrate rocks perpendicular to the direction of wave propagation. In 1906, seismologists discovered that seismic waves travel much slower in the Earth's core than in other sections. Even more interesting was the observation that S waves did not penetrate the core, while P waves passed through it easily. Only at the boundary of the core did an interesting deflection occur. From these observations, scientists concluded that the inner core is solid, while the layer above it is liquid, and the core of iron and nickel in the innermost became solid due to high pressure. In 1936, researchers again found that seismic waves reflected off the inner core, indicating a transition from a liquid to a solid state. Thanks to these discoveries, we now know that Earth's core is composed of complex layers, and geologists have an advanced understanding of Earth's evolution. The connection between the Martian core and the magnetic field reveals shocking connections between the planet's interior and the magnetosphere. Based on seismic data, the Martian core was found to have a liquid consistency throughout, while Earth's core consists of a solid inner core and a liquid outer core. The research suggests that the composition of the Martian core, particularly the presence of lighter elements, contributes to this phenomenon. While Earth has a strong magnetic field generated by geodynamo activity in the outer liquid core, Mars has a much weaker magnetic field. This relatively weak magnetic field of Mars has implications for the planet's ability to protect its atmosphere and minimize the harmful effect of charged particles from space. Earth is almost perfectly protected from the constant particle bombardment from the Sun by its strong field, but Mars was hit with much greater harshness by solar winds. Unprotected, the particle streams from the Sun were able to affect the outer atmosphere of Mars and even eroded it over millions of years. Together with cosmic rays, the Martian atmosphere was so significantly depleted that the planet is now virtually unprotected. Mars's lower gravitational pull and lack of a sufficiently strong magnetic field have also allowed charged particles to penetrate the upper atmosphere and trigger chemical processes there. This led to the release of gas molecules, including lighter elements such as hydrogen and helium, into space. The changes in the atmosphere had an impact on the surface of Mars. While liquid water may have existed on Mars in the past, it largely evaporated or escaped into space due to the loss of the atmosphere and protection from solar winds. Computer simulations show that erosion by particle flows very likely contributed to the formation of Mars's distinctive geologic features. Today, the surface of Mars is characterized by dusty and rocky expanses, dried-up riverbeds, and vast volcanic areas. In short, we could say that Mars slowly dried up, and if there ever was life on it, it disappeared with the water and with the increase in radiation. Our Earth, on the other hand, was able to support life to this day because of its robust magnetic field and dense atmosphere. Yet today, in the face of climate catastrophe, we naturally wonder if such a fate also awaits our planet. The parallels between the effects of solar winds on Mars and current changes on Earth are unmistakable. Our human activity has resulted in more and more greenhouse gases being released into the Earth's atmosphere. If nothing changes, we will destroy our atmosphere ourselves, and our homeland will also be more and more exposed to the influences of the sun and the cosmos. Already today, the fragile ecosystems and the general basis of life are threatened. The comparison with Mars shows how delicate planetary balances are and how important it is to protect the Earth and find sustainable solutions. So far from just opening up a potential new home for humans, the exploration of Mars also serves to better understand what is going on our planet and what consequences we should expect. But let's move away from the dramas currently unfolding on our home planet and look further afield to Mars. Mars is not as lifeless as previously assumed. On the contrary, a force is currently awakening inside the planet that scientists do not yet really know what it means for the future of the planet. Unusual Mars quakes alarm scientists. During its 4-year active phase, InSight detected hundreds of Mars quakes, but it wasn't until 2021 that things got really interesting. That year, InSight documented 2 unusual quakes on the opposite side of the planet. One was a massive Mars quake, larger and more powerful than ever recorded before, while the other was the result of a meteorite impact. These events on the opposite side of InSight were a windfall for science. The lander was now able to analyze waves that not only traveled around Mars but also passed through it, once again providing researchers with new data and details about the structure of the core. Exactly this data completed the picture in a way that we now know Mars has a liquid core. But the findings go much further. Thanks to the new data, scientists were able to analyze the elements inside in great detail. For the first time, it turned out that the core of Mars has a high proportion of lighter elements. Large amounts of sulfur, followed by smaller amounts of oxygen, carbon, and hydrogen, make up nearly 1/4 of the planet's weight. Exploration of the interior of Mars continued to be exciting. On May 4, 2022, InSight recorded the strongest Mars quake ever measured. The seismic shaking of the Martian subsurface reached magnitude 5. Mars. Failed missions to the Red Planet, either due to launch mishaps or malfunctions upon arrival, resulted in significant losses, leaving uncertainty about the fate of future attempts, including the InSight mission. InSight faced challenges right from the start, with a previous launch attempt delayed due to a vacuum leak in the SEIS instrument. However, after overcoming this hurdle, the spacecraft detached from the rocket stages in Earth orbit and floated freely in space for 6.5 months, covering a distance of 484 million kilometers. On November 26, 2018, it entered the thin atmosphere of Mars at 125 kilometers above the surface, hurtling through at almost 20,000 kilometers per hour and enduring temperatures of around 1,500 degrees Celsius. To ensure the delicate instrument's survival, InSight was securely packed in a protective cover. The final descent involved a parachute and small rocket engines to safely land the probe on Martian soil. Upon arrival, InSight began deploying its solar panels and taking initial measurements, marking the start of 4 years of exciting Mars exploration. InSight's mission was to explore the interior of Mars, overcoming the limitations of previous missions like Viking 1 and Viking 2 from the 1970s. These missions had seismometers, but their technology was not comparable to InSight's capabilities. Viking 1's seismometer did not work properly, and Viking 2's measurements were poorly calibrated, leaving questions about seismic activity on Mars unanswered. InSight, equipped with a seismometer, a windscreen, a highly mobile robotic arm, and powered by solar panels, aimed to survey and explore Mars' interior. It carried a complete small weather station and a robotic arm called the Mole for digging into the Martian soil. The mission faced challenges from sandstorms that affected the solar panels, but InSight provided invaluable data about Mars' seismic activity, weather, and climate. The seismic experiment revealed Mars' lack of continental plates, unlike Earth, and showed that the Martian surface resembles a single solid crust. The thickness of the crust varied regionally, with 2 or 3 sublayers, providing new insights into Mars' geological structure. InSight's seismic measurements, totaling about 450 Mars quakes, unveiled surprising details about Mars' interior. The repetitive frequency of quakes resembled a human heartbeat, indicating more activity than previously thought. The probe's data also led to the discovery of an ancient magnetic field 10 times stronger than expected, suggesting a time when Mars had a denser atmosphere and possibly liquid water on its surface. The mission came to an end in December 2022 when InSight's power supply became insufficient. Despite its challenges and limitations, InSight significantly contributed to our understanding of Mars' interior, seismic activity, weather patterns, and the planet's evolution. See eye to eye on every detail, but they share a common goal: the advancement of space exploration. Elon Musk, the CEO of SpaceX, and NASA have collaborated on various projects, and their efforts align with the broader vision of expanding human presence beyond Earth. While SpaceX and NASA have different structures and approaches, they complement each other in the pursuit of space exploration. Elon Musk, with SpaceX, envisions making humanity a multiplanetary species, with Mars as a key target for colonization. NASA, being a government agency, focuses on scientific research, robotic missions, and international collaboration. SpaceX has been working on developing the Starship spacecraft, a fully reusable spacecraft intended for a variety of missions, including crewed missions to Mars. Elon Musk's vision involves creating a self-sustaining city on Mars and making humanity an interplanetary species to ensure the survival of the human race. NASA, on the other hand, has its Artemis program, aiming to return humans to the Moon and eventually establish a sustainable presence there. The Moon serves as a testing ground for technologies and systems that could be crucial for future Mars missions. While there might be differences in the approach and priorities of SpaceX and NASA, both entities have expressed interest in Mars exploration. SpaceX sees Mars as a potential destination for human settlement, while NASA views Mars as a target for scientific exploration and understanding the potential for past or present life. Collaboration between SpaceX and NASA has included partnerships for cargo and crew transportation to the International Space Station, ISS. SpaceX's Crew Dragon spacecraft has been used for NASA's Commercial Crew Program, ferrying astronauts to and from the ISS. It's important to note that the relationship between SpaceX and NASA involves a complex interplay of competition and collaboration. NASA has been a significant customer for SpaceX's services, and the private sector's capabilities have played a crucial role in advancing space exploration. In summary, while Elon Musk and NASA may have different visions and approaches, they share common ground in pushing the boundaries of space exploration. Their collaboration and competition contribute to the collective effort to expand humanity's presence in the cosmos. And other Mars rovers, we would see a planet with a fascinating history and complex terrain. The information gathered by these rovers has opened up new avenues of understanding about Mars, from its geological features to the potential for past life. One notable structure mentioned earlier is Orcus Patera, an elliptical elongated lowland plain surrounded by a mountain wall. This structure spans 40 kilometers in width, 380 kilometers in length, and has depths ranging from 400 to 600 m. The origin and formation of Orcus Patera remain a subject of speculation and debate among scientists. The elliptical shape suggests that its creation might involve complex geological processes or an impacting celestial body with an unusual trajectory. Mars, with its diverse topography, also hosts valleys like Cas Vallis. Cas Vallis, formed 1.5 to 3.5 billion years ago, bears witness to the flow of water volumes reaching up to 1 billion cubic m/s over its 2,500 kilometers length. This valley, shaped by ancient water erosion, provides insights into Mars' watery past. In addition to natural structures, the Martian surface is marked by countless impact craters, created by asteroids or meteoroids colliding with Mars. The International Astronomical Union (IAU) and the U.S. Geological Survey (USGS) manage the names of these impact craters, often choosing names inspired by famous scientists, science fiction authors, or smaller cities. The presence of volcanoes is another prominent feature on Mars, with examples like Hyras Mons and Elysium Mons. Hyras Mons, standing at 1.1 kilometers high with a 450 kilometers diameter, showcases radial lava flow channels. Elysium Mons, discovered by the Mariner 9 probe, differs from other volcanoes in the Tharsis region by lacking grooves or furrows caused by lava flows. Mars exploration has been a collaborative effort, with NASA at the forefront. Various rovers, including Sojourner, Spirit, Opportunity, Curiosity, and Perseverance, have played pivotal roles in collecting data about the Martian surface. The discoveries, ranging from the presence of essential elements to carbon isotopes that hint at possible past biological activity, have sparked intrigue and raised questions about the potential for life on Mars. Elon Musk's vision of colonizing Mars faces significant challenges, from the harsh living conditions to the necessity of a sustainable source of water. The prospect of terraforming Mars, altering its atmosphere and climate to make it more Earth-like, has been discussed as a potential solution, though it remains a complex and debated idea. In conclusion, the exploration of Mars has been a journey filled with discoveries, mysteries, and challenges. The collaboration between private entities like SpaceX and governmental agencies like NASA reflects a shared goal of advancing our understanding of the Red Planet. As we continue to unravel the secrets of Mars, it remains a beacon of curiosity and a potential frontier for future human exploration. Exploration. The intricate patterns and formations observed on Mars, such as the flower-like structures in the Gale crater, serve as invaluable clues to unravel the planet's geological history. The Gale crater, with a diameter of almost 93 miles, provides a unique window into Mars' ancient past. The flower-like object captured by Curiosity's images is not a fossilized coral, as one might assume, but a geological formation shaped by the presence of water billions of years ago. This formation represents a snapshot of a time when Mars had flowing streams and accumulations of water on its surface. The intricate landscape features, including dried-up river channels and canyons, bear witness to Mars' watery past. The researchers, led by Timothy Gouge of the University of Texas, delved into the question of how water interacted with the Martian surface. The investigation focused on the possibility of crater flash floods shaping the terrain. The study identified 262 structures that seemed to have their origins at the edge of craters and displayed no connection to other river networks. These dried-up river channels, formed by crater flash floods, painted a surprising picture of Mars' geological history. The force of the released water accumulations, stemming from the bursting of crater edges, could have eroded an estimated 14 trillion cubic meters of sediment. This erosion accounts for nearly 25% of the material eroded in Mars river valleys. One particularly striking example of the forces at play is the Ma'adim Vallis, a mile-deep and 500-meter-wide channel. The researchers propose that this colossal Martian valley was also shaped by a crater flash flood, highlighting the immense power and scale of these ancient water-related processes. Understanding the history of water on Mars is crucial for scientists seeking clues about the planet's potential to support life. The investigations into past water flows, river valleys, and the role of crater flash floods contribute to a more comprehensive understanding of Mars' geological evolution. As researchers continue to analyze and interpret data from Mars missions, the enigmatic red planet reveals more about its ancient dynamics and the forces that shaped its landscape billions of years ago.